This planet shouldn't exist, and scientists have no clue how it could even have formed. Its name is PSR J2322-2650b, about the same size as Jupiter, but with characteristics that place it in classification somewhere between a planet and a star. There are three main things to cover: the star that it orbits around and how that affects the observations, how the star affects the planet, and the atmosphere that makes no sense. The star is a pulsar, a neutron star, which is very compact that rotates at high speeds and emits beams of electromagnetic radiation from the poles. Specifically, it is what is known as a millisecond pulsar, completing one full rotation every 3.46 milliseconds. I know it sounds insane to have exoplanets around pulsars, let alone find exoplanets around pulsars, and that's fair. I haven't found a consistent exact count, but we have less than 10 exoplanets that we know of around pulsars. The way we can find them is like you have the Doppler effect with a regular star, where you can tell the star is getting yanked around a bit by a planet because its color shifts between more red-hued and more blue-hued. The planet is also yanking on the pulsar, which is messing with the timing of when the beam crosses across where we're looking. But there is something that's really cool about looking at exoplanets around pulsars, and that's the fact we can actually see them better than around regular stars, depending on the instrumentation. A lot of the instrumentation we use to analyze the composition of exoplanets and their atmospheres is in the infrared range, and as you can imagine, regular stars give off crazy amounts of infrared. Pulsars, however, give off mostly gamma rays and other high-energy particles that are invisible to infrared instruments, so because of that, we can actually get a cleaner spectra of the exoplanet, and it can be tracked through its entire orbit instead of just a small portion. Now, this planet is crazy close to the star, with only 1 million miles between them. Comparatively, the Earth is about 100 million miles away from the Sun, so the planet is 1% of the distance we are. Because it's that close to the star, its entire orbit, its year, is only 7.8 hours. From this closeness, as well as the fact that the pulsar is much more massive than the planet, there are intense gravitational forces on the planet that are pulling it into what is described as a lemon shape. The type of system that it is hypothesized to be is a black widow system. These systems are when you have your fast-spinning pulsar with a smaller, less massive companion, and in the earlier stages, material from the companion object flows into the pulsar, increasing the pulsar spin. This results in a more powerful wind coming from the pulsar that, when paired with its intense radiation, tends to strip material away from the companion to make it even smaller. However, usually this companion is another star, not an exoplanet. The fact that it's a black widow system ties into the main reason why this planet is so interesting: its atmosphere. Typically, when you're looking at an exoplanet atmosphere, you're expecting chemicals like hydrogen, helium, water vapor, carbon monoxide and dioxide, methane, ammonia, nitrogen, etc., depending on the type of planet and its temperature. This planet has a bulk of helium, which is one of the most common bulk atmospheric molecules for gas giants. But the really only other prevalent chemical they found is molecular carbon. Those are molecules of just pure carbon, C3 and C2. There is no known formation mechanism that would create an exoplanet with only helium and carbon in its atmosphere. So then, what if it was a star that was then stripped into an exoplanet, starting off like a regular Black Widow system? Well, that doesn't fully track either, because the nuclear physics in stars don't tend to make pure carbon like that. So then what the hell is going on? Well, Roger Romani from Stanford, who is an expert on Black Widow systems, has a hypothesis. As the companion, which was a star that started to be stripped before core helium burning, begins to cool down, the carbon and oxygen within the interior crystallizes. The resulting pure carbon crystals would float to the top and mix in with the helium. Well, there is some unknown process that is keeping the oxygen and any possible nitrogen away from integrating into the atmosphere. What that process is, they have some beginning hypotheses in the paper, but you can bet that researchers are going to be studying this planet into the ground, or, well, I guess into the metallic helium, since gas giants don't really have a ground.